All right, now the hard part is over, and we have the top chord dividing successfully into a number of panel points. We have the trim length adjusting the bottom chord. The depth is working, and the length is changing. We have the parametric elements that we need. We need to now use... We have the parametric elements that we need. What we need to do now is use components to create diagonal lines using another subdivide of the bottom curve, the new bottom chord, and then creating sets of lines in between these. Before I do that, I'm going to take this line we just created, and I will rename this bottom chord for reference, which will be very helpful. So now we have a top chord that's clearly labeled and referenced, a bottom chord. We've divided the top chord, and we're going to similarly divide the bottom chord in the next step. What we need to do is take the number of panels for the top chord and divide it by one fewer. So we've done that before. We use the math tabs and a subtraction component, and we take that number and we subtract 1 from it. So we could just take this panel over here, copy that. That's our number 1. If you ever needed to change it to 2, you could, but that would make an awfully strange looking truss. We can put in another divide curve component over here, like the top chord. We're dividing that curve by this number. And so now we have 4 spaces on the bottom, 5 spaces on the top. So they are working in the right proportions, right? We're ready to go. With these divisions, though, we're going to do a few things. So let me zoom out for a minute using the scroll wheel, just like in Rhino, and zoom in because we're moving over on our canvas and it's a little hard to see. So we are going to take these divided points, and we're going to put them into what are called point buckets. In the Parameters tab, you'll notice one of the first things you see is this point component. This is not for creating points, this is for containing points. And one reason why we would want to do this is because we can bring one wire full of points in here and then take it out to multiple places and then plug in and unplug different things to them. One of the things I'm going to do now is also display points so that we can see them on the window on the left with numbers, and so we can pay attention to what numbers they have. So the tool that we're going to use to display the points comes from the Display tab, and it's this 1, 2, 3, 4 point list display. And we're going to put this down twice because we want to display both the points from the top and the points from the bottom. So we'll do them as separate lists so that we see them separately. So I'll just bring in another copy of that and put in this set of points. We don't see anything yet because we need to control this with a number for the font size, the size of what we're looking at. And all of this is a little too far away, so I'll just slide it over to the left a little bit. In fact, I can start to compress this a little bit so in the end we don't take up quite as much of the screen. But I need a number, so I'll use one of my number panels, and I'll bring this over and see what I get. If I put a number 1 into each of these, I get numbers that I can read, sort of. You'll notice that the numbers here, if you can read them, I can make them a little bigger. I can make this 2. Remember, don't hit return, just say OK. They get a little bit large, but my top chord subdivision points go from 0 to 5. And remember, computers start counting at 0, not at 1. But the bottom chord goes from 0 to 4 in the opposite direction. And so there are 2 things we could do. I know the reason why, and that's because when we made the bottom chord, we put this number at the end or beginning and this at the end. Now we could switch it around, right? We could just flop those 2 wires and they're in the proper position. If I didn't want to do that, I could drop another reverse in there, which is what actually the screenshot that you have of this definition does. So I'll go back and I'll do that just so it looks like the screenshot. But keep in mind that Rhino and Grasshopper are very logical, and Grasshopper is working from left to right, and this bottom chord goes from A to B, and the A I gave it was over at the far end, and the B is at the near end. So the thing I can do with this this list of points is just drop a reverse. So I can double click on the canvas and type in reverse. In this case, I don't want to reverse a vector, I want to reverse a list. So I can put in a reverse list, and I can drop in the list from here and pull it out that end, and now it takes the same list and it just reverses it. This is necessary troubleshooting if things are not working the way that you see them, but keep in mind that I could have solved this just as easily by just changing the inputs to the bottom chord line so that the line was made in the other direction. So now we see our two sets of points, and again, the numbers are large right now, so you can refer to them. These update; they're good for reference. You know, if we have more of them, we can see what's going on, and this will help us when we work on making the diagonals, just so that you know what's happening, and then we'll not visualize those anymore after that. So the first thing that I can do is I can just make a simple 2-point line using the curves and the line 2-point component, and I can take the points of the top chord and connect them to the points from the bottom chord and make a series of lines. Now you'll notice that one of the things that happens is that they have an extra, so they go from 0 to 0, 1 to 1, 2 to 2, 3 to 3, 4 to 4, and then there's a little more that's coming up. So in the screenshot that you have of this definition, and really for the purposes that we have, it's okay to have this extra line. So because the top list is longer, it has 6 components going into it, 6 values, and the bottom has 5, it will actually create in the end lines from 0, 0, 1, 1, 2 to 2, 3 to 3, 4 to 4, and then it has another one to do, and then it'll do 4 to 5. So it'll use 4 again. There's a way that we could clean this up. We could ask it to do the shortest list, so type short and get shortest list in here. And we can take these two lists and run them through this kind of shortest list filter. It's going to compare the two lists and then output the A's and A's, A's to the A's and the B's to the B's, but it will shorten the B list or the A list so that each list is now 5 values long. The A list came in as 6 values long and the B list 5. So you see that there are just these lines that connect 4 to 4 and do not connect 4 to 5. So let's leave this in here for now, but this will work without that. It's good to know about the shortest list component. And we're now going to ask it to draw lines thinking in a different direction. So we want it, instead of going from 0 to 0, we want it to go from 0 to 1, 1 to 2, 2 to 3, etc. In order to do that, instead of asking it to take a list and find the shortest value, we're going to ask it actually to shift a list by one component. So I can double click and say shift list, which comes from the sets, and under lists you can ask it here to shift list, right? So it wants the list that it's going to shift. We're going to take the set of points from the top, another wire out of there, and it wants to know how far to shift it. And we want to shift it over by one value. So we can take one of our panel components and get a number 1 panel component. And we can put that in there, tell it to shift by 1. It also wants to know if it should wrap the results. That's the W, right? And here we could actually use a panel component. And we could, instead of saying wrap or not, we could put it in the word false. And remember, don't hit return. Just type in false and say OK. And this is going to tell it not to wrap the results, right? So this now says false. If we disconnect that, then we're not controlling it with that, right? And what it starts with is true as its default for this, right? So this is telling this is it's just a switch, a Boolean, whether it should be to wrap the list or not. And we can look at the results, making another line component, and we're just going to use a 2-point line again. And in this case, we're going to be using the shifted list for one input and the set of points from the bottom chord division for the other. And so you can see that what we've got now is a series of lines on the left, if you look closely in green, that connect the 0 to the 1, the 1 to the 2, 2 to 3, 3 to 4, 4 to 5, and then 4 back to 0. And that's because this list is wrapping itself around. So I could either use a shortest list component to try and get these lists to be in alignment, or use this false switch to tell it not to wrap at the end of this shift of numbers, so that now this set of lines only go from the shifted numbers from 0 to 1, etc. And the first set of lines only goes from the 0s to the 1s to the 2s, 3s, 4s, connecting those. So there's a logical sequence, and we've had to control the lists here by shifting the order of the list over by one place. Notice if I change this to 2 places, look on the left to see what happens. Now these diagonals go from the 0 to the 2, the 1 to the 3. If I change this to a 3, right, the lines go in all sorts of different ways. So we want to shift, we're just shifting this by one position. We're shifting a list. So the list comes in looking like that, and it comes out looking differently. And we're controlling that with a number 1 for how far to shift that list, how many steps, and a false for whether to wrap when it gets to the end of all of the numbers it has, not to go back to the beginning and start over again. So we now have our diagonal lines. In fact, we have all the lines that we need. The only thing remaining to do is to pipe these, and this is where it gets really simple. We'll use the surface tab, and directly below that you'll see the pipe command. So that's an easy one to find. You could also type pipe if you want to. And we're going to use it twice. Let's set it up here, and let's, from the params tab, give it a slider. So we have the slider, and we want to edit it in order to tell it that we want it to go from a minimum value of about 0.1 feet up to a maximum value of something not more than about 1 foot, let's say, right? That should be about enough. And so that's going to be the radius for these pipes, and we're going to use we're going to use a different radius for both the top and bottom chords and for the diagonals. So let's take all of that componentry, copy and paste, move it down here, so that the first thing we can pipe are the diagonals, bringing in the center line geometry. And when you want to connect 2 sets of wires to the same input, you have to hold shift to get both of these to come in here. So now I have the diagonals, which can be very skinny, 0.1, and up to 1 foot, which is too fat. I might want to edit this actually to make the top end a little bit lower, maybe only 0.5 feet, let's say. But now we're going to connect geometry wires to the other pipe from the top and bottom chord. And it's good that we named them so that we can come back here and see them. And so we're going to bring in the top chord and then the bottom chord, again holding shift so that we get 2 wires into the same input. I can move these around by windowing them a little bit to try and clear out a little bit of the overlapping wires here, just so you can see your definition. And we could come back and also rename these so that you know what they are later. But now we can have a fatter top chord and skinnier diagonal chords. And they work very well. The entire definition is very solid. The truss can get longer and shorter, deeper or shallower. We can angle its ends efficiently and add a lot more diagonals if we want to. Now, there are things that we might want to hide along the way. If you want to get points in geometry when you bake, you can bake those in. If you want to see them, if you want to see those numbers, you can leave them, or you can hide them from the visualization. In the end, what we're going to do is most likely only bake these pipes into our final model when we want them, when we have them in the configuration that we want. And we might also bake the centerline geometry, because that can be useful for setting up other things. But essentially, this definition is now complete. It looks just a little bit different from the one in the screenshot that I gave you, but not significantly. I added this shortest list component here to not duplicate a last diagonal as it would do in that screenshot. But otherwise, and functionally, they are exactly the same. They work exactly the same. So thank you. Good luck with this first part, and we'll be doing a lot more with Grasshopper in the days and weeks to come.